Good evening. Welcome back to lesson 5. In this lesson, we'll want to look at text filtering. Now, what we hope to achieve in this lesson is to understand the meaning and the purpose of term by document matrix. Now, basically, term by document matrix is a structured representation of the corpus. The second objective is to understand what and the purpose of weighted frequency. And third is to understand the concept and why we are assigning term weight for a term in the document corpus. Now lastly, we want to understand the relationship between terms or words. Now, the text filtering phase is probably the last data preparation activity before we actually do the text mining. Now, in this text filtering, basically we are filtering more terms that are not significant to our text mining process. So we want to know how to do that. Just a recall what we have done in our data preparation so far. Now, after we have collected the data, we do text parsing. Now, in text parsing, we extracted out the words from the corpus into a bag of documents, and then we normalize it, we stamp it, we limitize it. After that, we try to refine it through the stop and start list and limitization. Now, the whole purpose of doing the text parsing is to get rid of those insignificant terms, alright, that is not useful for our text mining. Now, by removing them at text parsing, we have not actually lose any information from the corpus. Now, after text parsing, we still have a lot of terms that is carried over to the next phase. And we understand that not all the terms that remains after text parsing are equally significant. So in text filtering, we are trying to identify which terms that are more significant than others. And that's why we use what we call term weight and frequency weight. So just to recall again, the key purpose of the data preparation in text mining is to transform the unstructured form of text in the original corpus into a structured form. So we represent the structured form through what we call a matrix, or what we call a vector matrix. Now sometimes it's called term by document matrix. So how does a term by document matrix look like? Okay, this is an example. Supposing I have this corpus of documents. Now, in the vector space representation, or in the term by document matrix representation, it will be a logical table with the rows and columns. Now, each row represents a term that has been extracted, and each column represents the document which contains those terms. For example, the term complexity. Now, complexity are found to occur twice in document 1, 0 occurrence in document 2, and document 3 occurs 3 times, document 4 occurs twice, and document 5 occurs 3 times, assuming the corpus is only about 5. Alright, and what we do, the numbers here, we use what we call the frequency count, although this is not the best way, as you can see later. So let's look at an example again. Now supposing I have these three documents, right? First document, I am an avid fan of this book. I love this book, and so on. Now in passing this document collection, it generates the term by document matrix, which we also have seen earlier on, similar one. So all the terms is extracted out, and the numbers here represents the frequency count of occurrence in each document. Now note that each entry in the cell shows the raw frequency, right? So this is the raw frequency. So a term by document matrix is a table-like structure. Now what can we observe about the term by document matrix? Now if you look at it again, you can see some observation. First, you realize that the size of the term by document matrix will grow exponentially as more documents are added to the corpus, because more terms will be extracted. So the matrix will be a very large one. And you also realize that this matrix is quite sparse, okay, as there's a lot of zeros in the entries, as you can see from here, the example previously. You can see that yeah, there's a lot of zeros. The matrix is actually very sparse, and they are basically all negative numbers, either 0 or positive number. So as mentioned earlier, it has high dimensionality, that means many rows and columns. So as we add more documents into the corpus, the size of the matrix will increase exponentially. Now the question is such a metric useful for our analysis? We'll stop here. Now just now we see that the term by document matrix with a raw frequency is actually a very huge one. So it has high dimensionality, that means a lot of rows and columns, and many of these rows are actually very sparse, right? That means with 0 entries. The question is whether such a metric of terms is useful for our text mining analysis. Okay, let's recall again the objective of text mining. It is really to differentiate documents in the corpus. That means when we look at a text document, we really want to know what it's all about, right? Just like when you read a page of text document, you are actually trying to find out what is the gist, what is a key topic in the text document. So you're actually looking for significant terms, keywords that will help us to distinguish or discriminate what is this document about, right? So in other words, we understand that not all the words in the same document are equally important. Alright, some are more significant than others, and the significant ones, if we manage to find, will actually help us to understand or help us to identify the gist information of that document. Alright, so in the term by document matrix with raw frequency, so we want to get rid of some of those terms that are not significant. They are not a good discriminator. Right, and that's why we want to further filter them off during this phase of text filtering. So according to the field of information retrieval, as a guide, a good discriminators are those terms that is neither too high or too low in raw frequency, and they have a document frequency between n divided by 100 and n divided by 10 for corpus or n documents. Now, document frequencies refers to the number of documents that contains the term. Just for example here, assuming n is 10, that means, n is 1000, that means we have 1000 documents. So the term, the word term, recover, has a term frequency of 80 in 65 documents. That means to say that the term recover appears 80 times in the 65 documents out of the 1000. So using that guide, we find that this term recover actually is a good discriminator. Alright. So we can see that the raw frequency of occurrence word in the document is not a good indicator of whether the word is significant. So that's why we want to use what we call the weighted frequency. Now the general idea of weighted frequency is basically to assign a weight, okay, an objective value to a term to identify globally whether in this given document corpus they are actually significant word. But in order to calculate the weighted frequency, we need to understand three other terms: term frequency, document frequency, and size of corpus, because the weighted frequency are based on these three parameters. So let's define them. Now the term frequency refers to the number of occurrence the terms appears in a given document. In a given corpus of document. I think this one we probably have come across. The document frequency refers to the number of documents which contain that terms. And the size of documents is the number of documents in the corpus. So let's look at an example here. For example, the word government. Is a noun, it's alphanumeric. It occurs 970 times in 83 documents. Now that means the term frequency of this word is 970 and the document frequency is 83. Now the size of documents of course refers to the total number of documents in the corpus. So when we want to calculate the weighted frequency of a term in the corpus, we make use of two concepts: the local weight and the global weight. The weighted frequency of a term is the multiplication of these two concepts. So let's look at what we mean by a local weight. The local weight, or sometimes we call frequency weight, is the transform weight of a term within a document. That means it measures how important the word is or the term is within a single document. So normally it is derived by using a function and applied to the raw frequency of the term in that document. But the general idea of the function is that those terms that occurs very frequently or very often in a document are assigned a higher weight, a higher local weight, as they are usually considered more important since they since they best describe the document. So if a document have a lot of words about durian, right? So we know that this document is basically the content is talking about durian. Okay. Now in SAS, although this is not SAS created function, but they make use of the log and binary. Okay, so in SAS, when you choose a calculation of a local weight, you cannot use a log, uh, which is the log of the frequency count within a document plus 1. And the binary here refers to whether the term is present or absent. So if you use binary, then the value is only 0 or 1. Okay. So if the term occurs one time or many times, the value is 1. It's only 0 when the term has 0 occurrence in that particular document. So you can take a look at this example here. Supposing the fruit appears 28 times in document A and 17 times in document B. So based on the log function, the local weight of the document, of the term fruit in document A is 1.4 and in document B is 1.2. So in that sense, we say that the document A has a higher local weight. Now, with thousands of terms extracted from each document, the key question is whether all these terms in the document are equally important, or are they important. The local weight only help us to understand the composition of a document, that means the content. It does not help us to identify or discriminate whether these terms are important in the whole corpus of documents, which is actually what we want to analyze, right? So it is important not just to understand the local weight, but we need to understand whether the term is significant or important in the whole corpus of documents. And that's why we need to understand the meaning of global weight, right? Each term, they have local weight, but they also have a global weight. Now, the global weight or term weight is assigned to a term based on the overall frequency and document frequency within the corpus of documents. So remember, the local weight only calculates the weight within one document, but global weight calculates the weight of the term within the whole corpus. Right? So in TextMiner, we use 3 methods of calculating the global weight: entropy, inverse document frequency, and mutual information. Now, although these 3 techniques seems to be different, but the underlying assumption is the same. The assumption is that the term which occurs many times in a few documents within a corpus tends to be more significant in the discriminating function. So there are 3 methods or 3 techniques that we normally use to calculate the term weight or global weight of a term in a corpus: entropy, inverse document frequency, and mutual information. Now, when we talk about entropy, the concept is actually related to information gain. Now, intuitively, when we look at certain words, we know that certain words actually give us more information than others. Okay, for example, we have a set of corpus of documents relating to COVID-19. Now, the word contagious, when we see the word contagious, probably it will give us intuitively, we know that it's an important word, and because it will give us more information than the word health. All right, the word health probably occurs many times in the corpus of documents as compared with the word contagious, which tends to occur less infrequently. So the word contagious intuitively give us more information, and therefore we assign a higher entropy weight to it. Now this is a formula for calculating the entropy. Although I put it here, but you don't really need to understand the formula, how it's being calculated. But basically it tells us that the entropy weight, this is the entropy weight of a term I, okay, is dependent on the total number of documents and its frequency that occurs in each of the document in the corpus G, right? So this is yeah. So the less frequency the term occurs in the corpus represented by Gi, it will has a higher weight, right? Because it's at the denominator. As I say, we don't really need to understand them, to really know how to calculate. But this is just a mathematical way of assigning a value to a term weight. Now this is the result, alright, of using entropy using SAS, enterprise minor. Now in this image here, the term calcium has a global weight of 0.971. Okay, it occurs 108 times in the whole of corpus, but it only occurs in very few documents, 4 documents. As compared with the word global forum, now you can see that the weight is actually much lower. Now it has very high frequency in the whole of documents, and it occurs in also many documents. So those documents that have high frequency of a term tends to have a lower entropy weight, right? So this is the entropy weight. Now next we talk about inverse document frequency. Now this is another method for calculating the global weight. Now basically the idea of document inverse frequency tell us that the more documents that contains the term, the less significant the term is. Alright. So if a term appears infrequently, it is considered more important and it will be given a higher weight score compared with a term that has high frequency appearance. Good morning. Before we end the lesson, I'd like to introduce the interactive filter viewer. Now this is found in the property panel of the text filter node. Now this feature is quite useful uh, because it allows us to manually modify the list by either dropping or keeping the terms. Now what happened after applying the techniques of parsing and filtering? The result is that you will still encounter some terms that is not important but are retained, and also some terms that are important but was not kept for analysis. So we can open up this filter viewer by clicking at the three dots here on your property panel. Now when you open up this filter viewer, you'll see a window that looks like this, and you can see that for each of the term that has been extracted, it tells you the status of what term are being kept and what term are being rejected or dropped. Now those terms that has been kept are actually checked, right, under this column keep. So we can actually manually modify them by unchecking if we don't want, or check those terms and bring them back again to the matrix, right? The term by document matrix. Now over here is a respective weight, okay, of the terms. So the filter viewer are actually very useful. It actually helps us to do the final refinement. Now also in the viewer you can see that some of the words have a plus sign on their left. Now the plus sign tells us that those terms or those words has actually been normalized. Okay, they are reduced to their root word, as we learned in text parsing. So if you want to find out what are the variants of the word of the term, you can actually expand by clicking on the plus, right? It will show you all those variants of the base word that has been displayed. Now the other thing I want to highlight to you is that in the text filtering node, there's this concept link. Now basically concept links show us the linkage of words, the words that co-occurrence together in the documents. It actually gives us an idea and insight to the relationship between certain words. Now how do we open up the link here? How to open up the concept link is that in the same viewer window, okay, you can actually right click on the word, and then you can see the drop down and you select concept link. So when you select, you will get an expansion of the words that's linked to the words that were selected. Now in my case here, in my case here, I selected the word calcium, and you can see that calcium is linked to quite a number of words. So, but the line between calcium and the words represents the relationship, okay, of the words. So the thickness of the line actually represents the strength of the relationship. So for example, in the diagram here, the term calcium is strongly associated with the term vessel, right, and hormone than with other words, as you can see. So if you were to just mouse over the graph, okay, you can see two numbers. Okay, now in this particular case, you see 2/4. Now what that means is that out of the 4 times where the word hormone and calcium occurs. Okay, sorry, let me repeat again. Now, all out of the 4 times where calcium appears, right, 2 of those times it appears together with the term hormone. Okay, so this is quite helpful because it can give us an insight to the documents. All right. So we will not actually dwell into this, but this is just to show you uh, mathematically we can calculate the strength between 2 terms, all right, using this formula. So it depends on the formula depends on the number of documents which contains B, the term B, and K is the number of documents which contains both A and B, right? That means that, and P is the probability that the term A and the term B co-occurs together. So the concept link is actually quite useful because it can tell us about certain things. For example, if there's a strong link, strong association between the word customer and the word rude, then we know that one of the for example, in the customer reviews, one of the complaints could be that the customers are very rude. Okay, so it is a great feature to investigate the relationship between the words in the corpus lah. When you come to analysis, especially when you uh, use it with topic extraction. So we have come to the end of our lesson. This is what we have learned, covered today. It's quite heavy. Okay, what is the term by document matrix? The weighted frequency of a term. Okay, this is different from the raw frequency because the weighted frequency gives us more uh, accurate measure of how important a term is in the corpus. The local weight measures the content of the term within a document. Okay, and the global weight help us to understand the significance of the term within the whole corpus. Then we also learn about the concept link, right, which help us to understand the co-occurrence or association between 2 words. Okay, thank you. Okay, I want to explain the inverse document frequency technique again. Now, this is a technique for calculating the global weight of a term in a corpus. And this technique depends on the document frequency of a term. So what is the document frequency of a term? Let's recall. It is the number of documents in the corpus that contains the term. Alright, so if there are 1000 documents in the corpus, so if 30 of the documents contains the term that we are concerned, then the term document frequency is 30. Now the IDF calculates the importance of the term as an inverse of the term document frequency. So that means to say that the term will be given a lower IDF weight if its document frequency is very high, so reverse, and given a higher weight if its document frequency is low. So if a term occurs in many documents as compared with another term which occurs in fewer documents, then the term will have a low weight of IDF as compared with the other term. So in the extreme cases, the IDF weight value will be 0. if the words appears in all the documents in the corpus, and therefore it has no significant effect in terms of discriminating the documents. Now, for example, terms like the, right, which probably will occur in every document. Now, so the maximum weight for IDF for term is only when it occurs in exactly one document. Now, even though the weight is maximum, but probably it is not so important. Now, please watch this video, which is also uploaded in the OCL section. So this is the formula for calculating the weight using the inverse document frequency. So the same thing, this one refers to the weight of the term, alright? So this is the result that you can actually see when you run the text filtering. This is one of the window. Now you can see that they actually plotted for you. So in the horizontal axis is the number of documents. This is the weight. Okay, the global weight using IDF for that corpus of documents. So you can see that the term uncompressed occurs in 4 documents as compared with the term fine, which occurs in 96 documents. So you can see that the term fine is given a lower weight because it has high document frequency. The term uncompressed has a low document frequency of 4, therefore given a higher weight of 6.2. Now next we talk about the technique in calculating the global weight. Now basically the word mutual information means that in order to assign the global weight to a term, we take into consideration the co-occurrence of the term with another term. Alright, so mutual information can be derived as the difference between the entropy of the variable x, which can refer to a term, and the entropy of the variable x with the condition that x knows y. So what it means here is that in text mining, this can be thought of a measure of how much the presence of one term in the document tells us whether the document belongs to a particular category, for example in classification problem. So in the gist of mutual information is that sometimes we tend to discover that two terms, alright, or similar terms tend to occur in the same document, right? So the calculation of entropy will depend very much on the occurrence of the other term, right? So it's like a bit like conditional probability, right? When we do probability calculation. So what is the application of this? Let's look at the example here. Supposing our task is to classify a corpus of 3,000 reports into different categories, such as sports, health, finance, and politics. Now, in this particular problem, we tend to use mutual information technique to calculate the global weight, because we know that for documents that likely to fall under the same categories, most likely they will have common terms. They will have terms that occur together, or most of it in the same document, right? So these terms tends to co-occur in the same document if they belong to the same category. So this is the concept of mutual information. So the entropy takes into consideration of the co-occurrence term in the same document. So this is the filter node in the text parsing. As you can see, you can choose the frequency weighting, right? The term weight, which is the global weight. The frequency weighting is actually the local weight, right? So you are given either log or binary. So what happened after the results of text filtering? So this is the term window. You can see that there are more terms that are being so-called dropped or rejected. So after assigning the weights to those terms that comes out from text parsing, in text filtering we further refine the significance of the term by assigning a weighted frequency to them. So remember the weighted frequency is of a term is defined by the global weight times the local weight. Okay, you can see from here. Sorry. Okay, the weighted frequency of a term is defined by the local weight times the global weight. So if a term has a high local weight and a low global weight, alright, its weighted frequency overall is still not significant, right? Because the local weight only tells us the content, but that content is not significant when you take into consideration the whole corpus, because the global weight of those terms are actually quite low.